Before we dive into an example, let's take a look at the definition of components. And you've talked about this last semester, so this should be fairly simple, fairly much of a review. So let's say we have a coordinate system here, and you have the y-axis and the x-axis, and you have some vector. And I'm going to try to draw things in color here, just to kind of make it easier to see. Okay, so you have some vector, and if I take projections down and across, I can project onto the x-axis, and I can project over to the y-axis, and I have some angle theta, then I can break this into two vectors. I'm going to have this blue vector along the x-axis, and I'm going to have a red vector along the y-axis. So this magnitude in the y direction, Fy, is equal to our magnitude of the F vector. And the F vector, we're meaning this guy over here. So it's the magnitude of the F vector times the sine of theta. And for our blue vector, F sub x is going to be equal to the magnitude of the F vector times cosine of theta. Now, if I want to get back to my vector definition, then I really need to know magnitude and direction. I need to know the magnitude or length of this vector and the angle that it would make with the x-axis. So to get back, this F vector, the magnitude of it, is going to equal the square root of fx squared plus fy squared. Now theta is a little more tricky because we have the different quadrants. We have quadrant 1, we have quadrant 2, quadrant 3, and quadrant 4. Well, quadrant 1 is easy, so we'll do that. If quadrant 1, then it's the arctangent of Fy over Fx. If 2, then, well, in this case, I know that y is going to be positive. So my Fy is going to be positive. Is greater than 0. but fx is going to be less than 0. And to get theta, well, the projection is going to go like this, and theta is going to be referenced to the x-axis. So this is just pi, or 180 degrees here on the x-axis to the left. So theta is just going to be pi minus the arctangent of the absolute value fy over fx. Don't forget the absolute value. Or I could say 180 degrees if I want it in degrees. If 3, then I have fy less than 0, fx less than 0. That's going to put me in this direction. And that's just going to be pi plus the arctangent. And because both of them are negative, I don't have to worry about the absolute value sign. Of course, absolute value you can do anytime. It's not going to matter because it'll just give us a positive. Whether the number is positive or negative, it'll always give us a positive. And again, I can do 180 degrees. And if 4, then fy is less than 0 and fx is greater than 0. And I'm going to have, I can do this so many different ways. I can view this as a negative number. I don't mind in the fourth quadrant being a negative. So minus tangent of theta times fy over fx, and I need to put an absolute value sign in here. So that's one possibility. Another possibility is 2 pi minus, oh, forgot my arctangent function. The arctangent of the absolute value of fy over fx. Or this could be 360 degrees minus the arctangent of the absolute value of fy over fx. So these are how we define, these relationships are how we define the component review, the component view, and breaking problems down into this component view. In 2 dimensions, it can make the problem a lot easier. So let's start with the next video, start with our problem.